Hello my dear students and a hearty welcome to all of you for this academic year 2021-22. Today I am going to teach you a new lesson from Science 1. Before we begin, I want you all to observe these two pictures. So what do you observe in these two pictures? Yes, in the first picture you see that there is a bird which is flying, and the second picture you find that some of the leaves are falling, right? So do you think so there is some common thing in these two things? Yes, there is something common. So if you see the flight of a bird, that means a bird is moving. Even the falling leaves are moving down. That means both of them are in motion. So you guessed it right. We are going to study a new lesson, that is laws of motion. So before we begin and go into detail of the lesson, first I want you all to think about these two questions. Suppose you are traveling in a bus or maybe in a train, and if a person is sitting next to you is in motion. This is the first question. Second question, what do you take into consideration to decide if an object is moving or not? Okay, so let's begin with the first question, that is you are traveling in a bus or maybe a train. So here there are two people sitting here in this train. Okay, and you find that both of them, if you look at them, they are moving in the train, right? But the question is, if you are traveling in a train or a bus, and if a person is sitting next to you, do you find that person in motion? Think about it. Okay, so think that you are traveling in a bus now and somebody is sitting next to you. Do you think so that person is moving? No, you'll find that with respect to you, that person will not be moving. But if someone outside the bus or in a train outside, okay, observes you, he or she finds you and the person sitting next to you both are in motion. Correct? That means motion is a relative concept, and it is a relative concept with respect to the observer. Okay? Wherever may be the observer. Now, if the observer is sitting in the train or in the bus, moving bus, the passenger sitting next to him, you will find that passenger at rest. But if someone observes from outside, he or she will find that the person sitting next to you is in motion. That means it is a relative concept with respect to the observer, whoever is observing. It can be for an observer, a person sitting besides him in a vehicle may be at rest. But for other person outside, they find that you are in motion. Right? Second question, let's try to answer. The second question was, what do you take into consideration to decide if an object is moving or not? Now here in this picture you see a car is moving. But how can you decide whether this car is moving? If you carefully observe this car, okay, this car has changed its position with respect to its surrounding. So when it is changing its position from buildings to the this factory, again to the buildings, that means it is changing its position with respect to the surrounding. Surrounding includes here the factory, the buildings, okay, so windmill here, okay. So there is a change in the surrounding with respect to the car's position. Therefore, we can say when it is changing its position with respect to the surrounding, then it is moving. Otherwise, if the surrounding does not change, we say that the object will be at rest, right? So let's try to conclude now what we have just now thought about the two questions. The first question says that the motion is a relative concept. It for one person, the other person may be in motion, but for some other person, that person might be at rest. So it is a relative concept with respect to the observer. Second question, if the position of an object is changing, then only with respect to the surrounding, then only we say that the object is set in motion. Fine, otherwise it is said to be at rest. Only if the position of the object changes with respect to the surrounding, then that object is in motion. Otherwise it is said to be at rest. I hope so you have understood these concepts, right? Now let us little move forward. That is, we will learn now about what is the displacement and distance. Both the terms seems to be similar, right? Yes, but we will try to find out now what is the difference, what are the differences between these two words, displacement and distance. Okay, now here is an example, a picture from your own textbook, that is page number 1, figure 1.1, location of the school and the house. Okay, so here the house which is showed here is the red color, that is Sheetal's and Prashant's house, and yellow color house is of Sangeeta's house. Fine, whereas the school is shown in blue color. Now here the question is, Sheetal first went to her friend's house, that is Sangeeta's house. Okay, and on her way to the school, and then from there Sheetal went to the school. Fine. Second is, Prashant went straight from home to school. Fine, you can see that there is a way out from home to directly to the school. Fine. So both are walking with the same speed. That means Sheetal as well as her brother Prashant both are walking at the same speed. Then who will take the less time to reach the school and why? Now if you carefully notice here, Sheetal first goes to Sangeeta's house, that is her friend's house, and then she goes to the school. So that means she travels path A and then she travels path B. That is, path A is around 500 meters and path B from Sangeeta's house to school is 1200 meters. So that means she walks 500 meters plus 1200 meters. That comes to around 1700 meters. Whereas Prashant walks directly from home to the school, that is only around 1300 meters. So definitely Sheetal will be reaching, Prashant will be reaching the school faster as compared to that of the Sheetal, though both of them have the same speed, because Sheetal takes travels along the correct paths, actual paths. Okay, whereas Prashant is walking a minimum distance. Okay, so Prashant is walking a minimum distance and Sheetal is walking the actual path. Fine. Now in these cases, if you see, there are two things. Okay, actual path traveled by Sheetal, okay, and the minimum distance covered by Prashant. So this tells you two things. One is distance and second is displacement. Now let us see what are the definitions of these two. So distance is nothing but distance is the length of the actual path travelled by an object in motion while going from one point to another. So that means Sheetal has covered the actual length, actual path travelled. Okay, whereas Prashant has taken a minimum distance. That means only the displacement, right? So this is the difference between the distance and displacement. So distance is the actual length of the actual path travelled by an object in motion while going from one point to another, and displacement is the minimum distance between the starting and the finishing point. Fine. So let's try to learn this more by taking some more examples. Like for example, the example given on page number 2, that is use your brain part. Now here here you can see a circle, right? It is actually the edge of a circular field, okay, and it is having a radius of 100 meter. Now every morning Swarali walks around the edge of a circular field which is having a radius of 100 meters. Okay, are you getting my point? Every morning Swarali walks around the edge of a circular field having a radius of 100 meter. So as shown in the figure, if she starts from point A, that point is shown by the dot, a black dot here, right? And takes one round, okay, takes one round. How much distance has she walked and what is a displacement? Now, if you see, you have learned about distance and displacement. Distance is the actual length or the length of the actual path travelled. So here the length of the actual path travelled would be the circumference, okay, the circumference of the circle. So therefore, to find out the distance, we will have to take into consideration the circumference of the circle. Fine. Whereas the displacement is the minimum distance. So minimum distance would be the point A itself, correct? The minimum distance would be the point A itself, and therefore the displacement will be 0 because there is no displacement at all here, because minimum distance itself is the same point. So displacement becomes 0, but the distance, since it is the length of the actual path, it becomes the circumference of the circle. And you know, circumference of the circle is given by the formula dash 2 pi r, correct? So you can find out the distance travelled by Swarali every morning. So this is your homework for today. How much is the distance travelled by Swarali? Displacement is 0 because the minimum distance is the point A itself, right? Now let's go for the second question. Here you can see a car. If a car starts from point P, you can see point P and point Q. If a car starting from point P goes to point Q and then returns back to the point P, how much distance has she travelled and what is its displacement? Now again it is the similar thing. So here the length of the actual path would be from P to Q and again from Q to P. That means double the distance. And here the distance which is given from point P to Q is around 360 meters. So if it is from P to Q 360, therefore from Q to P also will be 360. So the distance travelled would be 360 plus 360, which comes to around 720 meters. But since the displacement is the same point, okay, it has to come back to the same point. That means it will be 0 again here. Fine. And always remember, displacement is related to direction, whereas distance has only magnitude. Displacement has magnitude as well as direction, and therefore since the direction is opposite, it gets cancelled. Okay, it gets cancelled, and therefore here the displacement becomes 0 again, whereas the distance is 360 plus 360, that is equal to 720 meters. So we can say here that the displacement is 0. Now even if the displacement of an object is 0, but the actual distance traversed by any object may not be 0. That you have to take into consideration, or you have to remember this. Okay, even if the displacement is 0, but the actual distance traversed by any object may not be 0. Fine. Now let us move ahead with the next part of the lesson, that is speed and velocity. Okay, before that I would like to ask you certain questions. Can you recall what are the vectors and scalars, or what are vectors and scalar quantities? Now, vector and scalar quantities are nothing but the physical quantities. like that of you have learnt now distance, displacement, time. Okay, so speed, velocity, all these are called as physical quantities. Okay, so both vectors as well as scalars are physical quantities. But what are vectors and what are scalars? So vector quantities, if you remember, are those quantities that has magnitude as well as direction. Magnitude as well as direction. Whereas a scalar quantity only has magnitude. Remember this. Okay, that is size. Magnitude means some size or some number. Okay, whereas vector has both magnitude and direction. Second question, which of the quantities, that is distance, speed, velocity, time and displacement are scalars and which are vectors? Now, just before few minutes I mentioned to you that the distance is a scalar quantity because it does not has direction, it only has magnitude. Whereas displacement, I told you, it has direction, both magnitude as well as direction. That means displacement is a vector quantity and distance is a scalar quantity. Now let's talk about speed and velocity. Speed and velocity, once you learn about them, I will mention to you whether they are vector or scalar quantity. Then next is time. Time does not have any direction. It only has magnitude and therefore it is a scalar quantity. So again I'll repeat, vector quantity has magnitude and direction. Scalar quantity only has magnitude, no direction. So distance, displacement and time are scalar quantities. Distance and time are scalar quantities. Displacement is a vector quantity. Let's now learn about speed and velocity and find out whether they are vector or scalar quantities. Okay, now speed and velocity. Okay, what is the definition and the formula of speed? Now you might have seen when you might have sat in your father's car or maybe on a scooter, there is always a speedometer fitted for the scooter or the any vehicle, fine, which shows you the speed 10, 20, 30, 40, whatever. Okay, the normal speed people use is 40 to 60 kilometers per hour, correct? So what is that actual speed? What is the definition of a speed? Speed is nothing but the total distance travelled upon the total time taken. That means whatever is the distance covered by the vehicle and how much time it is covering, that decides the speed of the vehicle. Whether it is travelling 10 kilometers in an hour, then its speed will be 10 kilometers per hour. Then if it is going 120 kilometers per hour, that means in 1 hour it can travel around 120 kilometers, then its speed will be 120 kilometers per hour. So that is the speed. Okay, so it is measuring, speed is related to the distance. Remember, speed is related to the distance. Okay, so since speed is related to the distance, that is the length of the actual path, that means since distance is a scalar quantity, speed also will become a scalar quantity because it also does not have direction, it only has magnitude. Next is velocity. What is velocity? Velocity is the actual distance travelled, the distance travelled in a particular direction in a given time or in unit time. Again I will repeat, it is the distance travelled in a particular direction by an object in unit time. So that means here we are talking about direction also. And which quantity has direction? It nothing but the displacement. So displacement has both magnitude and direction. Therefore, velocity is related to displacement. And in simple manner, the formula of velocity is displacement upon time. Now, let us talk about their units now. In both SI unit, that is a higher unit, and lower unit, that is CGS unit. That means in what terms we can measure them, how we can measure Okay, so speed, first of all, distance or displacement, it is measuring some distance, right? So distance is always measured in meters, and you know time is measured in seconds. So therefore SI unit of both the speed as well as the velocity, okay, would be meters per second, whereas the CGS unit, that is a lower unit, okay, below meter, is centimeter. So therefore lower unit or CGS unit is centimeter per second. Both of them have the same unit. So therefore let's try to conclude what we have learnt now here. Always remember, okay, always remember, the units of speed and velocity are the same. In the SI system, the unit is meters per second, while in the CGS system, it is centimeters per second. Second thing what we have learned is speed is related to distance while velocity is related to displacement. Therefore, speed is a scalar quantity, velocity is a vector quantity. Now, if the motion is along a straight line, the values of speed and velocity are the same. Now, if you see, if any object is moving along a straight path, so here straight path means there is no change in direction. Therefore, here in this case, the speed as well as the velocity would be same, because the distance and displacement are same. Okay, if it is along the straight line, there is no change in the direction at all, not even a U-turn also. So then the speed and velocity would be the same. Otherwise, if there is direction, change in the direction, then they can be different. Now, velocity is the displacement that occurs in unit time. So this I have already talked about, that velocity is the displacement that occurs in unit time, or it is the distance traveled by an object, okay, in a particular direction, okay, in a unit time, is also called as velocity. Now let's proceed further with the first page on the this. Okay, now let's relate the first example of Sheetal and Prashant with speed and velocity. How we can calculate the speed of Sheetal and velocity of Sheetal. Fine. Now, if you see the first example on page number 1, the straight line distance between the houses of Sheetal and Sangeeta is, from Sheetal to Sangeeta's house it is 500, and from Sangeeta's house to the school is 1200 meters. So that means the total distance is 500 plus 1200, that is 1700 meters. This I have talked about previously. Also, the straight line distance between Sheetal's house and school is around 1300 meters. That is the minimum distance what we have. Okay. Suppose Sheetal takes around 5 minutes to reach to Sangeeta's house, and then 24 minutes to reach to school from there. Then what would be the Sheetal speed along path A, along path B, then the average speed of Sheetal, and what would be the Sheetal's velocity? What would be Sheetal's velocity? So let's see Sheetal's speed along path A. Okay, so Sheetal's speed along path A would be, first you have to use the formula, that is distance upon time. So along path A, that means so distance upon time would be, distance is 500 meters, that is from Sheetal's house to Sangeeta's house, and she takes around 5 minutes. Therefore, distance upon time would be 500 plus 500 upon 5 minutes, which comes to around 100 meters per minute. Okay, so she is traveling, okay, very fast, 100 meters in 1 minute. Now, second thing now, that is from path B, that is from Sangeeta's house to school. So again, we have to calculate the speed, then the formula would be distance upon time. So here the distance from Sangeeta's house to school is around 1200 meters, and she takes around 24 minutes. So if you try to calculate, it would be 50 meters per minute. That means her speed has, reduced. The speed has reduced. Earlier it was 100 meters per minute. That means in 1 minute she walked around 100 meters. Now here she walked only 50 meters in 1 minute. Now, average speed, how to calculate? Average speed will be the total distance upon the total time taken. So, total distance is 1700 and total time is 5 plus 24 minutes, that comes to 29 minutes. So, when we back calculate, the answer comes to around 58.6 meters per minute. So, that is the average speed from path A, path B. Okay, so that would be the average speed. Fine. Whereas the displacement, Sheetal's velocity would be how much? So Sheetal's velocity is nothing but the displacement upon time. Displacement is the minimum distance and minimum distance is around 1300 meters and total time taken is 29 minutes. So that means here the average velocity of Sheetal becomes 44.83 meters, okay, per minute. So here you find that if you compare the average speed and average velocity, you find there is a difference. Why? Because there is change in the direction. If it was along the straight line, then the speed as well as the velocity would have been the same thing. Now let's talk about the effect of speed and direction on velocity. Now for that we have taken one example from the textbook. What can be the effect of speed and direction on the velocity? Whether the velocity changes or not. Now here Sachin is traveling on a motorbike. Explain what will happen in the following events during Sachin's ride. Okay, so the first question is, what will be the effect on the velocity of the motorcycle if its speed is increasing or decreasing, but its direction remains unchanged? Now here the speed is same, but speed is increasing or decreasing, but the direction is changing. Okay, direction is unchanged. So direction is constant and speed is increasing or decreasing. Will there be an effect on the velocity? Yes, of course, there will be an effect. There will be a change in the velocity. With the increase in the speed, the velocity will also increase, and with the decrease in the speed, even the velocity will decrease. Okay, why? Because the direction is remaining the same. That means consider that Sachin is riding along the straight path. Therefore, if the speed changes, velocity also will change. Speed remain constant, velocity also remains constant, and if the speed decreases, even the velocity will decrease. So there is a change in the velocity. Second thing now, when in case of a turning on the road, will the velocity and the speed be the same? Now here if you see, here the condition is, if Sachin changes the direction of the motorcycle. In the first condition, direction was constant. Now the direction is changing, but the speed is constant. What will be the effect on the velocity? Of course, at every point on the change in the direction, even the velocity will go on changing, even though the speed remains constant. Since the direction changes, even the velocity will also change. So there is an effect of the change in the direction, and by keeping the speed constant, even the velocity will change. Next, the last point. If on turning, Sachin changes the directions as well as the speed. Okay, if Sachin is now moving along the circular path only, and here direction is also changing, and he is trying to increase or decrease the speed accordingly. Will there be an effect on the velocity? Of course, yes. Even here also, since both are changing, the velocity is definitely going to change. So that means what we have learned in this, so we can conclude from this is that the velocity depends not only on the speed but also on the direction, and therefore that velocity changes by one. First thing is by changing the speed but by keeping the direction same. Second, changing the direction while keeping the speed same. And third thing is changing the speed as well as the direction. Right? So these are the effects of the speed and direction on velocity. Fine. So this is regarding today's topic what I have dealt with. Right? Now what you have to do is today is that you have to answer certain questions. Okay, when an object is said to be in motion, this is the first question. Second, you have to write down why motion is said to be a relative concept. Third thing you have to answer is what is distance, what is displacement, what is the difference between distance and displacement, then what are vector and scalar quantities. Then you have to answer what are use your brain power questions. Then you have to answer about what is the formula and the definition speed and velocity. What is the difference between speed and velocity, and what are the effects of speed and direction on velocity. So this will be your homework for today. Please read the lesson thoroughly. Then only you will be able to answer this question. Now of course one more question I have given you to calculate, that is to find out how much Swarali walks within when she takes a circumference of the circle, that is the circular edge of the field. When she walks, how much is the distance traveled by her. Fine. So these are some of the questions which you have to answer for your homework. So thank you dear students.